Hello, everyone. I actually received some questions about this worksheet 4. Let's record this video to just discuss all the questions in this worksheet 4. So now let's look at question 4.1. Men and women often disagree on how they think about selecting a mate. Suppose that a pool of 1,000 individuals in their 20s gave the following responses to the question of whether it is more important for their future mate to be good looking or smart. So this is a very similar question to the one that we have on the lecture notes. This is actually a 2x2 table, or we call it 2x2 frequency distribution. So that means we not only look at whether the good looking is important, we also look at the gender that who made those selections. So two-dimensional frequency distribution. So we have all the following count. And again, we have a 2x2 table, then we have a total of 4 cells. All the cell counts have information from both dimension. Either one dimension is the gender and another dimension is the whether good looking is important or not. Before we look at the questions, let's look at the marginal totals and the grand total. So, or we say we just finish this table with some important numbers. For those individuals who select good looking, regardless of gender, what's the number for that, or what's the frequency for that? Then we have 180 plus 120, that's 300. That again, that means we have 300 individuals select good looking. If we don't take the gender under consideration, 300. And same thing we can calculate for smart, 700. So altogether we have 1,000, and that is the grand total. Or we use capital letter N to represent the grand total. And then same thing, regardless of the choice, out of this 1,000 individuals, how many female and how many male participate. So then we can have for male, 180 plus 420, that's 600. And for female, 400. And we can verify 400 plus 600, that's again 1,000. So no problem in the calculation. So then we have the marginal totals and grand totals calculated. So we can just say total. So then we complete this 2x2 frequency table. And then we can look at the questions. Suppose each individual in the pool has equal chance to be chosen. If an individual is selected at random, calculate the probability of the following events. 1, the selected individual is a woman. So to simplify all the following process, we just say let A be the event that the selected individual is a woman. Then we want to calculate the probabilities of the following event. So for number 1, we just need to calculate probability of A because we define that event. And then F over N rule, because that is just a 2x2 frequency distribution, right? And then we have all the count, and then we're following the F over N rule, which is called the empirical probability. And then what's that? Woman, right? Female total is 400. So then we have 400 over 1,000. That is probability of A. We can simplify that because it's quite easier to simplify this one. So 4 over 10, which is 2 over 5, or 0.4. And again, for this kind of question, as long as you get a fraction form, that's okay. You don't have to write it into the decimal format. And then let's look at question 2. The select individual thinks good looking is more important for a future mate. So then we let B be the event. That the selected individual thinks good looking is more important. Then question number 2, we just need to calculate probability of B. So again, F Orban rule. Then we say good looking, right? We have that group 300, and then over the grand total n, which is 1000. So we actually have 3 over 10, or 0.3. And then both event A and B occur. Then we need to calculate probability of A and B. So that means what? Let's translate. We want the selected individual is a woman, and then we also want the selected individual thinks good looking is more important. Then what is the group for that? Good looking and female, right? 120. So then we have the count equals 120 over grand total n. So that's 0.12. Either event A or B occurs, that's probability of A or B, right? So either A or B, that means we want to find what any selected individual is a woman, and also thinks looking is important, right? So either a woman, so this number, this group works, right? So either a woman or thinks good looking is more important. So then we have those count satisfy for either or event. So by the F over N rule, so we have what? 180 plus 120 plus 280 divided by 1000, and then we calculate that. So we have, that is 400, right? 180, 120, 280, 400 plus 180, that's 580. 580 over 1000, so we got 0.58. So we call this is more like the definition way to solve the problem and using the empirical probability. Or method 2 to look at this question, probably A or B. We just, since A or B, and then we want a probability, we know there is additional probability rule, right? We can just use the formula. That is probability of A plus probability of B minus probability of A and B. So then we have what? Probability of A equals 0.4 plus probability of B equals 0.3 and minus probability of A and B 0.12. So that that tell us is 0.7 minus 0.12, 0.58. So either way, you're gonna get the same answer. So you can actually use one method to verify another method. That's question number 4. And then number 5, neither A nor B occurs. So neither A nor B. cannot be female, cannot think good looking is important. So actually, the only thing left is male that thinks smart is important. So then method 1, we can just use probability. We can just say probability of neither A nor B. So that's actually A or B complement. So that's the standard notation for this one, right? Either A or B. The complement of that is neither A nor B. So we use F over N rule, and then that is 420, because that represent what male that thinks smart is important. That's 420, so that equals 0.42. And the second method is probability A or B complement by the complementation rule equals 1 minus probability of A or B. So that one we calculated already, 0.58. So 1 minus 0.58, that gives us 0.42. And then question number 6. Let's change another color. Number 6, given that the selected individual thinks good looking is more important. So when we see given, we just draw a line and then put the given event right after that. Good looking is important, right? So do we define good looking? Yes, we let B define that, right? So given event B. So draw a line B. So we describe the given one. And then what is the probability of selected individual is a male? We use A, define female. The male is just A complement, right? So we actually want probability of A complement given B. So this is more like a translation using stat notation for the question described above. Then let's introduce the first way we can do it. That is the F over N rule. We use F star and N star because given B, that means we restrict all the information with the given event, right? Given selected individual thinks good looking is more important. So actually everything we have is right here, or we call it a block. So the blue shaded area is everything we have now. And then we want to calculate what probability of a complement, which means probability of male, right? Because A is female, probability of male. The select individual is a male. And then we just look at the count, right? Male count, 180. What's the total? 300. So that's 180 over 300. 0.6. So that's the first way we can look at the question, definition. And then let's look at a second way. So probability of A complement given B. That is what? That is use the formula now. Probability of A complement and B divided by probability of the given one, probability of B. So A complement means male, B means good looking. So male thinks good looking is important. So that's 180, right? So we have the count 180. And probability of that event, and event. So that's just 180 over 1000. And divided by probability of B, we have that, right? Probability of B equals 0.3. So then we got 0.18 over 0.3. And same answer, right? 0.6. And the third way to look at it is actually kind of special only for this question, because the number we have can tell us a little bit information specifically for this setup. Other question, you might cannot use method 3. Just stay with method 1 and 2. But for this one, we actually discovered that probability of A and B equals what? We can read the answer, 0.12, right? That is happen to be happen to be the product of probability of A times probability of B. Because probability of A we can observe, that's 0.4, what we calculated, right? Probability of B is 0.3. So for this specific question, we happen to have that equation or relationship between probability of A and B and the product of A and B. So that tells us what? That tells us A and B are independent. So this relationship indicates that A and B are independent. For most of the time, you don't have that. So that's why we say this is only good for this specific question. Independent. A and B are independent. And then when A and B are independent, we have A complement and B complement are independent. Are independent. Okay, so A complement and B complement are independent. And we also have A complement and B independent. A and B complement independent. So that what we can know for because we have that equation here, 0.12 is happen to be 0.4 times 0.3. Then we have all independency. Then let's look at the conditional probability we want to calculate again. That is probability of A complement given B. So A complement and B, they're independent of each other. So that means what? No matter whether put that condition there, doesn't really affect the value for probability of A complement. So it is, we can just say that is just probability of A complement. So put the condition restriction there, doesn't affect the probability of A complement. And then probability of A complement by complementation rule is 1 minus probability of A. So probability of A is what? 0.4. So that's 1 minus 0.4. That equals 0.6. Okay, number 7, given that the selected individual is a female, what is the probability if she thinks smart is important for her future mate? Then again, we have 3 ways to do that. Number 1, we have the definition way. So of course, we need to translate it first. Given the selected individual is a female, so given A, and what is the probability she thinks smart is important? Smart, we use B complement to represent that. So probability of B complement. So then we have what? F star over N star. So smart and female. So we have smart. Okay, this is the my bad. This is the first definition way. We have to look at where we block at. So given select individual is a female. So then we have the woman column block. it's hard to draw that? Okay, and then that means all the values we have are now the green shaded area. And then we want the count for smart, right? Smart, so that's 280. And then count for the total, which is 400. So 280 over 400. So we can calculate that. That's 0.7. And 2, probability of B complement given A. That is, using the formula, the second method, we have probability of B complement and A divided by probability of A. So we have A represent female woman, and then we have B complement smart. So woman thinks smart is important, so that's 280. So that's 280 over 1000 divided by probability of A, that is 0.4. So then we have 0.28 over 0.4. So that is 0.7. And the third way to look at this, again, only good for this question. So that is probability of B complement given A is same as probability of B complement because of the independent. And then that is 1 minus probability of B. That is 1 minus probability of B equals 0.3, right? So then 1 minus 0.3, so that is 0.7. Okay, so method 1 and 2 either way is fine. Method 3, just good for this one. And then that's all for worksheet 4. 4.1, question 4.1. Okay, and then we'll make another video for 4.2, 4.3, 4.4, and 4.5. And for this one, let's just stop here. Thanks for watching.